Hello. This says it's the Notary V2 working session. Unfortunately, due to the difficulties of recording and live everything, we've had to do the work for you. But we'll be doing some sessions shortly anyway, so do come along. But this is a summary of the work in progress for Notary V2. I'm Justin Cormack. I'm an engineer at Docker, maintainer of Notary, and I'm on the CNCF TOC, and I work with SIG Security, and I've got a real interest in security and cloud native.
Hi, I'm Steve Lasker. I'm a PM architect on Azure Container Registry. I work on things like TOB for OCI and registry work like OCI Artifacts and ORAS. And one of the things I really enjoy is just the whole end-to-end workflows from registries for dev to deployment, where registries play a key part of that. So we've been engaged in this Notary V2 thing for a while, and we're excited to share our progress.
So what is Notary V2 about? If you really want to see it from the beginning, we had an intro session, which you can also watch or attend. But the key things that we're really looking for in Notary V2 that we're kind of missing from the existing Notary V1 version, first of all, registry native. What we really mean by that was that Notary V1 was actually implemented as a database and application that you run on the side of a registry. But that causes all sorts of issues, it turned out, over the 5 years or so we've been running it, because it's not a native part of the registry, and it's not part of the registry protocols, and signatures and artifacts are not actually registry objects, and that makes a lot of things more difficult. So we really want everything to be natively part of the registry. Security, there's a bunch of security things that were not ideal with V1. Trust on first use was one that was particularly problematic for ephemeral servers. Trusting things the first time they call them, well, the first time is the only time, and so it doesn't really give you much guarantees. But there's other security guarantees we want to add as well. Portability, we want, as part of being registry native, we want every registry to support Notary, and we want to be able to move artifacts around, which was not a design criteria at all for Notary V1, because at the time there weren't a lot of registries, and there wasn't really that kind of multi-registry workflow that we've seen in the last 5 years building up. This is a kind of multi-tenant project for lots of people run very large registries for lots of users. Some people run private registries themselves, but they're often multi-tenant use cases. There's lots of offline use cases that, again, weren't really an issue with V1. It kind of can be persuaded to work with them, but it wasn't really a use case that was thought of at the time. And usability.
If you can't move them, then it kind of works in the offline scenario with your gap, because you can't move them anyway.
Yeah, that's as well. And then usability. We really want it to be much easier to use so that everyone can use it. So Notary V1 didn't meet all these requirements, but that's what we want to do with V2.
And the usability is a big deal, right? I mean, if something is super secure, but you can't use it, then people won't. Yeah. So it doesn't matter if it's super secure.
Yeah, absolutely.
Right? And we've got to balance that usability and security aspect.
Yeah, and V1 has not got the usage that we'd like, and that's one of the issues. And I think a lot of that's about usability. So there's a bunch of requirements. So we've spent a lot of time working on requirements. This is just a very short summary of them, really. There's lots more in the repo. Some of the things that we want is support for offline signatures. We want support for multiple signatures. People want their keys to be secured in external places like cloud providers, key vaults. Notary V1 has YubiKey support, but it wasn't designed for widespread use of external key storage. And it should work, whatever kind of user you are, whether you're a hobbyist or an open source project or a large vendor or anything. So different kind of keys are suitable for those kind of use cases. And then the ephemeral thing we talked about a little bit before, but that's something that's very important because that's kind of the essence of cloud native.
Yeah, it's kind of like a fancy word. I mean, like by ephemeral clients,
we just spin them up and down all the time. It's like that's what we do in cloud native. It's like, things are not long lived, and but it does affect the security.
I mean, just from cloud vendors, like we want you to be able to spin up containers super fast. And the idea is we have compute that's sitting there waiting for all customers, and when we hand it to you, like Justin gets an instance to run his container. There's nothing on it yet, so he's got no previous state on it, and that's what we kind of mean by the ephemeral clients. Is you get a something given to you, you use it, you toss it, and there's no state restored from a previous point.
But
we want to make sure.
But the security model has to account for those kinds of things.
So we were trying to put together a workflow that we would be able to communicate, and we'll spend a couple of slides here just talking about the communication model, because when you have so many people working on something, that has been the core effort. So we have this example. We have the Wabbit Networks and company, and they're putting together a network monitor software. They build it off on their own. They've got their own build environment. Doesn't really matter whether it's in a cloud or not. The point is they have a build environment. They're generating an image, their network monitor software. They have a bill of materials that says what's in it. They might even have some source for some open source projects for GPL licensing requirements and so forth. And they'll bundle all that. Well, they'll bundle those separately, the separate OCI artifacts you could submit to a registry. And you can put an OCI index on it to say, I want these things to be as one.
This is the kind of model that people are looking to now. At the moment, lots of people are just pushing images, but the whole bill of materials and all the other requirements have been quite important for the situations we've been discussing.
So when they put these things together, like a bill of materials and all of these things are only as good if you can trust them. So we want to make sure that the Wabbit networks can sign it with their key. So they now have their software. All those individual artifacts are signed and the index is signed. And then for discoverability, they want to be able to push it to a well-known location like Docker Hub. Now, as soon as you push it to Docker Hub, we want to make sure those keys can go with it. This is the transportability thing that we were talking about. So now Wabbit Networks has got some content up on Docker Hub, but they're kind of in the community space. We don't really know if they're good or bad or evil or just some random person. They have a key, okay, but don't really know about them. So what we want to be able to do is support scenarios where we could add another key for some trust. So Docker Hub might want to say, I want certified content, and you can do that more than just a badge on the page. We could actually have it signed by Docker IO and saying, all right, this now has a secondary key. So if a company like Acme Rockets over here has a policy that you could only bring content, certified content from Docker Hub, then they can now pull that. And they might be blocked by pulling it when Wabbit Networks wasn't certified. As they get to know and trust Wabbit Networks and other software, they might trust those keys as well. So those are the kind of things we're thinking about. But now, as with any best practice, I want to bring that network monitor software into the Acme Rockets environment because we don't want to deploy production stuff from public points of interest. It's not just a matter of whether Docker Hub is up or the DNS is still working or any of that. Even in the best case scenarios, if Wabbit Networks is publishing a security fix, which is still from them, that doesn't necessarily mean it's going to work in my environment. They might have done something around doing security patching that affects how the software would run in my environment and might fail. So we always want to have a certification process for any content we depend on. And so in that case, I would actually have an Acme Rockets key or a signature assigned to that content. So now I know that I only trust stuff from Docker Hub or Wabbit Networks, but I'm only going to deploy stuff that has been verified and proven verified by an Acme Rockets key. I might have a deploy artifact that I'm also signing, keep track of what I'm deploying. And then you would have something like a policy management infrastructure, like Open Policy Agent. And the idea here is that we have signatures that attest to what it is, but we're not stating anything about policy. We're not stating it has to be signed by 3 entities or anything. What we're saying is that's more of the policy management software's responsibility. And it can take that content and say, all right, it's signed with the Acme Rockets key. So, and it comes from the Acme Rockets registry, so I can actually deploy it in my environment. So that's kind of gives a sense of the workflow. We also can support air-gapped environments. That's also a core requirement. So all this validation and so forth can happen there. And air-gapped is kind of interesting because we used to think of air-gap requirements as being, the submarine scenario or the oil platform. But what we're seeing more and more is customers that have been on-prem and reluctant maybe to go to the cloud because they always had their private IP environment, that we can provide that in the cloud. They still get a private network, so they have more trust around it. And there literally is no public endpoints on inside of those environments, or the public endpoints are very tightly controlled. So prototyping things is the interesting one. So there's, as with any of these complex systems, we're trying to figure out how do we communicate amongst ourselves, because we want to enlist experts. There's no one person that actually understands all these pieces together. So how do we establish this model for communication to bring people in?
And we're trying to understand people's requirements, and because it turns out that these things are not clear. We're not totally clear at all.
So if I said, we as everybody watching this, we want to build a house together, what does that mean to you? Like, clearly that's not the extent of the house. I mean, I guess it's close to an A-frame, but if everybody's trying to picture that house that we're going to build, what is your bias? What is your background? What is the experiences that you've had that make you think about what is this house going to look like? And I can write words down. Right? We can write requirements and all that, but even those words get interpreted. And we think about the story we hear about books, right? We can all read the same book and come away with a very different perception and experience of what that story really meant. We all go watch the same movie and we're being told what to think and see. We might not all like the same movie, but we kind of all saw it the same way. So that's the next piece that we wanted to iterate on. So if I drew this, have this bathroom drawn up, and it's got two sinks, it's got the separate part for the toilet, it's got, a big shower and tub and the doors and everything, and we're ready to go. And
but Steve, this hasn't got a bidet. What are you doing? This is not a bathroom, not a complete bathroom.
Why would I need a bidet, right? It's like in the U.S. we don't think about that. Now maybe we should after the whole toilet paper COVID thing. So there's definitely some learnings here to think about. But okay, so we add a bidet. Now we can see that if we try to add it later, it really doesn't fit. We lost our door. The shower's like this weird closet now. So the point is we want this iterative approach. We want to make sure that we can bring all the subject matter experts in. You're one of our key masters, right? All of our security work. We've got Niaz from AWS that's been awesome for thinking about key management. We've got the Notary folks, the tough folks that have been working on all of the update semantics. And we each have our perspectives, but it's really hard to communicate with each other, without sketching these things out. Turns out sketching isn't just enough. If you look at the churches in Barcelona, right? The churches not just there, but other places. They were big and massive pillars inside to hold up these roofs that were concrete and then maybe a wood roof at the top. But they were just really massive structures. And Antoni Gaudí had a different vision for what he wanted to see, and he couldn't really figure out how to communicate that vision very well, or figure out how to build it, quite frankly. So he'd make sketches. And you'd look at it going, that's awesome, but I don't know how are we going to pull that off? It's like going to collapse on itself, or it'll just be so bulky. So he started doing modeling. He took his sketches and he was building models and prototypes. And this one was really interesting. So when we can all travel again or search online, if you go to the Strada Familia, that you'll see that this is actually strings that are hung from the ceiling with little shot pellets that are in these little canvas bags that help shape the formation that becomes the pillars that holds up the church, the Strada Familia. And he did a lot of these iterations. If you just look up Gaudí models, you'll just see the amazing things that he put together. And that was able to facilitate all the different trades to figure out where are they going to put the lighting, where are they going to put the gas pipes or whatever they used for electricity back 120 years ago.
They didn't have
So they
electricity.
well, that was what I was trying to figure out. So I guess with all the windows, where are they going to put the candles without burning everything down? So you had to figure out how to get all these different trades to fit in, whether it be stairwells or whatever. And that's what he was able to build these models that everybody could look. All right, I can put the pipes here because the things are not there and so forth. And, it's just an absolutely amazing sculpture. And you can just see the pillars and the way they look like trees and so forth. So the point here is not just to appreciate Anthony Gaudi, but it's that, communicate, write things down, sketch, prototype, and throw it out and start over again is the approach we've been taking with this project.
So we're in this prototyping phase at the moment. So prototype 1 kind of is really, Steve's going to talk about in a second, but that's a kind of exercise in generic signing of content in a registry context. How that would involve, how you can copy signatures, the air-gapped issues. We're going to look at key management issues, and what kind of persistence and retrieval there is for signatures. Are they separate artifacts or the same, or part of the same artifact? Detached keys or join keys. Are they all those kind of issues about what is a key in a register? What is a signature in a registry? And then that's going to lead into, in parallel, we're working on a lot of design decisions, and then nearly ready to start a bunch of other prototyping. So prototyping what tough looks like in a registry, looking at the issues around rollback in a registry context, and ephemeral clients we'll talk about in a few minutes.
So as part of building this prototype and doing this iterative model, we want to carve out what we really want to chew on right now and what we're going to defer. So we've got a prototype for an NV2 client, and all it does is sign and verify. It actually doesn't even know about a registry. It just knows how to sign content and verify that content related to that key. Of course, it can sign an artifact, and we're targeting OCI artifacts, and there's a manifest for how those things come in. We'll talk about that in a second. And based on that manifest, the digest, we can generate a signature. Once we have the signature and the artifact, we can push it to a registry using something like the ORAS client, which is, again, a good prototyping tool because it's really meant to be a library for other CLIs. But now we can see how we can leverage the OCI Artifacts model for pushing additional content into a registry with these tools, and we can get a kind of a rapid prototype going here. So we've started with X509 certs, and Justin will talk a little bit more around how we want to expand the type of keys that we support, key signing. But what was interesting about this is Shiwei, who's been working on this part of it, if we use the bathroom analogy again, he created some artwork on the wall in this bathroom that we weren't really expecting, and we're kind of all grokking it now. So let's kind of take a look at what this all happens. So we take an an X509 key, and the CNAME is the registry that the artifact was originally in. It doesn't limit where it can be pulled to. It's just saying we're going to have a certificate that has a registry baked into it. So we build an image. We're tagging it with the registry, the source registry. Now, this is where, to support offline scenarios, we needed a manifest locally. Manifests are typically generated as part of a push operation, and you can get it from the registry. So here we actually, Shiwei's built this generate manifest tool that you can, get a manifest locally, and you just pass it the name of the image, and you say, output it to this net monitor JSON file. So now I can take the NV2 client, and one of many methods we want to support is X509. So we had GPG and we pulled it out. We're trying to figure out how we want to do this best. But imagine there's multiple methods. For now, we do X509. I give it the Wabbit Networks key and the registry that I want to tag this thing associated with. And I pass it in the net monitor v1 manifest JSON file because that's what it's going to sign. And then the signature object it generates is the netmonitor.signature.json. Okay. So you got the Docker build, generate a manifest, and then I'm going to sign it. So that netmonitor signature JSON object, what we have here is the top part is the references to the certificate, the expiration, not before, and I always forget what IAT stands for. Then what we have is, it's called an OCI descriptor. What this says is, I am signing this artifact that's in the registry. It has a media type for whether it's an index or manifest list or index, manifest list or manifest. So this represents an OCI manifest. It has the digest. That digest is the digest of that manifest and the size. Those three parts are referred to as an OCI descriptor. And then here's the interesting part that we're playing with, is the certificate has to match the registry if you put it in here. And that's only for assigning. It just means that I can't use a different key, X509 key, to sign a different registry URL at that point. The output of that is the bottom section, that is the actual signature. So this is basically the config object that or the signature object that we've generated. And you'll see we have lots of conversations around the formatting of the white space, no white space, canonical, and so forth. But that's one of the debates we're having. So now if I've got that file, I can push it to a registry as a Notary v2 artifact. So I can use the ORAS client, and I say ORAS push to the Wabbit Networks registry. I pass it a manifest config of the JSON file, the signature object, and I've given it a Notary v2 artifact type. And the manifest of that as it goes into the registry is a 0-layer object. It's got the config object right there. This whole config object is the signature. And now I've got the artifact and the signature in the registry. So go ahead.
So key management obviously is an important part of this, and that's something that this experiment has kind of illuminated a bunch of things about it. First of all, it used X509. Actually, one of the interesting things about Notary v1 is that you could choose to use X509 or kind of ad hoc keys, and that was actually kind of giving people a choice was actually kind of weird, because it meant that there was functionality that you could do with X509, like see who had signed an image much more easily. But you couldn't rely on that functionality being there because some people didn't use X509. So it was a kind of mixed bag. I think some of the functionality was quite nice, but no one ever liked to rely on it, because X509 keys are really mostly used for signatures as opposed to for TLS in the US government and a few other large organizations. They're not widely used elsewhere. And unfortunately, you can't use a Let's Encrypt cert for signing a normal object for reasons that I won't talk about now. But it does give this potentially useful binding, but maybe between the name and what you're signing for. But maybe there are other means we can use. Some people are kind of in the GPG ecosystem, which comes with this web of trust thing, but really only Debian is the only user of that. And in these COVID times, we don't go to key signing parties, even if we ever did. And it's not clear that the web of trust model is real.
I was wondering where you were going with this COVID reference of key parties. Okay, now
and so ad hoc keys is which is what Tough specifies, although Tough does say you can use other kinds of keys as well, which is why Notary was able to use X509 is probably the most likely option. But we're still going through the kind of options there. Definitely, we know we want to be able to manage keys with existing tools, particularly hardware security. So things like Cloud Key stores or HashiCorp Vault or the Parsec project or YubiKeys, which Notary v1 had support for. So there's a bunch of things we do know, and there's a bunch of things that we're still experimenting with there.
And part of this is coming because, like we showed the bathroom and, with the bidet conversation or the multiple keys, it's like one of the things we're debating is should we support multiple keys? Because we want the hobbyist to not have to pay anything and super simple and have maybe the appropriate level of trust associated with that. Where larger software vendors, or maybe it's a more critical workload, or even a company that wants to have their certificate more trusted, there's that realm as well. So these are just kind of some of the things that we've been debating around, because now we can see what this thing's starting to look like.
So there's we spun out a key management group on Fridays to go through these issues. On the prototyping roadmap, one of the things that really, once we've experimented a little bit, we've got some sort of concrete experiments with putting keys in OCI. Then there's an interest in mapping the update framework into OCI registry types, because it's a design for files in a file system, and mostly Notary v1 carried that over because it had a separate database. But as we want to put things in the registry, there's some little differences. Some of them are just small things, like OCI descriptors include the MIME type, whereas the tough pointers, which are much the same, don't include a MIME type. But it's just a minor thing. If we use external signature objects rather than tough signature objects, tough signatures are in line. If we're standardizing on external signatures in the registry, then that makes little differences to the layout. I mean, this is fine as long as it maps and it preserves the security properties. I mean, tough does say that these are examples and not required, but we need to do an exact mapping. There are a bunch of options, but we need it to be OCI structured with, at least to some extent, with the OCI structure, because that's how registries do garbage collection. We don't want signatures to be, or tough metadata to be garbage collected. So or images that are pointed to from that metadata.
Eventually.
Well, yeah, eventually, but we want them to be managed in the normal workflow of the registry. And then there's some other questions about putting tough in a registry that we've discussed a bit. So Notary v1 made a tough repository equal to a registry repository, i.e., so Docker Hub / Justin Cormack / my program. That would be one tough repo. That meant there were a huge number of keys. The tough team think that the whole registry is the right scope, but I don't think we haven't convinced the registry operators that that's not too large a scope. So maybe the answer is in between. It's the org scope, or anyway. So there's still some work there, but that affects things like how delegations work, and there's a whole lot of complex issues around discoverability of information about signed objects and things that also affect the design. So it's a complicated thing that we need to make some more progress on that. More design work, that we're having an ongoing discussion about rollback protection, which is a really interesting subject. I'm writing some blog posts on this at the minute to just kind of sort out my thinking about this. But there's a bunch of articles that Justin Kapos has written on this. So there's a problem with the tough models kind of assumes that you have a persistent history again of what's been going on, and then so someone can't come along and just say, oh no, there haven't been any updates for the last 3 years. The latest version is the one from 3 years ago. You should use that.
Which is still signed by the same
still
entity.
Signed, so it's still valid. It still looks valid, but you should know that there's actually been updates since. And so one solution is to update the client and tell it in its base image, tell it that where the state of the world was when it was created, but that's more work. We've also been looking at there's a relation between transparency logs, which are kind of used for public attestation of TLS keys and certs and things like that. And there's a very interesting relation between those and the kind of the rollback protection, but it's complicated and we're still working on that. I think we know that ephemeral infrastructure is important, so we need to work out how to use it effectively and keep it secure.
I mean, it's kind of interesting. This is one of the reasons this is interesting to debate is like for deployment, we kind of follow this best practice that every deployment is a unique tag. Right? You would never deploy latest. You should never be building on latest. Latest is good for like demos and trying to get things started, or even a deployment. Right? Having a single tag in an environment where you have lots of nodes, you want to make sure they're all running the exact same version. So we don't really think of the update scenario being part of the deployment, but on your build statement, like your from, we do want to use what we refer to as stable tags. I want node 9. And when there's a new security update to node 9, I want to get that without having to change my Docker file to reference a new tag. So we definitely have these kind of semantics. It's kind of where is it in the priority list and where do we carve off? And we need to solve the complexity and the reliability of this part of it. So
I mean, I think there's some of the ways in which we decide, in the practice of using containers, things, everyone understands that latest is has been an issue ever since it was kind of created. And so, we need to think about questions like, over time, was that the right design, and do we need to try and change that over time? But one of the design criteria of this project is we're not trying to change what people do. We're trying to make what they do secure, because changing this kind of thing is hard. And if you tell people they have to change before they're secure, they're quite likely to just not change and carry on being insecure. So we have this difficult thing of trying to work with things as they are, even if they're not necessarily ideal, but it's important to kind of explore how we could make things better by making change, but we can't assume that we make those changes first. So this is kind of summarized a little bit in this slide, but the update framework is concerned with updates, but there's not a good model in the registry of what updates are. And I looked at the Ubuntu repo in Docker Hub, and it's got 386 tags, and technically 5 of them and kind of latest are up to date, and the other ones are probably old, and you shouldn't probably be using them most of the time. This kind of thing, that we're discouraging use of latest, and people want immutable tags, but actually most of the immutable tags are mainly for historical interest, and you shouldn't actually be running them right now because they are old. So, I actually I've been thinking about this quite a lot recently, and I think we did make some. I do think there are some mistakes here in terms of the way the design was.
Wait, you're human?
Well, these things have been around for a long time, and there are some right things about them, and some, I think we need to tweak them a little bit. But it's, these things are kind of, the usages are kind of in the sort of fabric of how people use things now, and it's definitely going to be a challenge to change them. So this is Sagrada Familia a couple of years ago.
It's the top of a SpaceX rocket. Like, did Barcelona go off and make a rocket silo in the top of this thing?
So we're building this thing. It's not going to take as long as Sagrada Familia. We're actually, shipping things quite fast now. We've got, we're next KubeCon, we're going to have prototype in the state that everyone can really play with it and get their hands on it before we shift it into production. So come and join us. The details are on the next slide. Yep. So we have weekly meetings. Do get in touch with us. Get in touch with me and Steve directly, and we'll be around to answer questions. And so thanks very much for listening, and there's a lot of work to do. So let's have a working session.